Hello YouTubers, here we have an interesting ATX power supply. It's for computer. The model number it's DPS-250AP-24C. It's automatic, 100 to 250, 240 volts input. The output is the common as any ATX, 3.3 volts, 5 volts, 12 volts, and here is the output amperes. It's made in China as all ATX power supply. It's a Delta. It's really interesting. The interesting thing about this ATX is the thickness of it. It's about 4.5 centimeters. It uses a 4-4 centimeter fan, the thick type. Now I'm going to open it. Let's see if I can open it with a single hand. Here's the inside of it. The complaint is that the customer brought this, told me it stopped working. Taking a look inside of the circuit board, I'm going to show you it. Here's a look inside of the circuit board. Now I remove the transformers, and now the transformer, regardless of being dirty, super dirty, it's working fine. There is no shorting in it. There's no short in the winding whatsoever. It's a Delta also part. It's a really interesting transformer and really interesting unit. Now, according to the size of the transformer, this unit will produce up to 200, maybe 250 max of wattage. Here's the start transformer. I'm going to flip the circuit board and to see what causes of the malfunction. The causes, or the reason it got malfunction, is the dirt and the dust inside of it. It became a conductive dust and made a very big short inside of the circuit. Here's the other side of the circuit board. As you can see, here is the position of the main power transformer that will produce the 12 volt, 3.3 volt and the 5 volt rails. This is an interesting transformer. This transformer is for driving the MOSFET, that which can drive the output or the main transformer. There is no bulge capacitor here and no blown capacitor. The main fuse is 6.3 electronic fuse. I believe they call it this way. Let's focus, or it can 6.3 amperes, 250 volts. it's blown. The MOSFETs are not shorted, but an interesting isolation around here is it's not mica or that flexi rubber or thermal rubber they used for as a thermal paste between the transistor and the cooler. The bridge diode is not shorted. What I found, it's rather interesting. Here's the power diode for the 12 rail and the 5 volt rail. Here's the 30 ampere one. Here's the 20 amperes one. Now, look what happens when now the way to test these type of diodes is as follows. You set your multimeter, which is in this case an analog meter, which I found it very accurate, on the 10K range, and measure the leakage as so. Now it's very hot. Okay, there's no leakage. Okay, okay. The irrigator clip was a little bit loose. Here we go. Okay, one side it's fine. Flip the polarity switch. Here's the leakage, which is a little bit high. Now, in order to test if the diode is working right, we're going to apply some heat through my soldering iron to it and see how it's going to behave. If the leakage increases rapidly, this diode needed to be replaced. As so, I'm going to link the alligator clip to one lead of the ohmmeter, and the other as so. Here's the leakage. Here's the tip of the. Now watch the. Whoa. I removed the. Now it hotted a little bit, and the leakage rise up so fast that I couldn't even what kind of the short it will happen if this applied a true AC current in the circuit to it, and it's not barely even warm, just a little bit heat, and here we go. Now comparing this type This is a 20 ampere one with a new one made by ST Corporation. Okay. Flipping the polarity switch. This is okay. Now this is how a good one will do. Here's the tip of the soldering iron. Little bit. Boy, it got hot. Yes, it got a lot hot than that one. With about 45 degrees or maybe 50 degrees or maybe even 80 degrees, you should get this much of leakage. Not like this one or this one. Now switching to the 30 ampere one and see. Okay. Okay. The same result. This is the leakage of it. Switching the polarity. And this side is good. And this side, okay. Oh my god. There is no way in hell this diode is fit to be installed in a circuit anymore. It has a high reverse leakage. It's Schottky diode, but it's also not like stable like the new one. Now this will replace this one, but this is a 30 ampere. I'm going to search my scrap or search for a new one in my part list and see how I'm going to repair this. Luckily we could not find another 30 ampere, so I'm going to try another way, is linking two of this 20 ampere in parallel so it can give 40 ampere, 20 in each diode. Now this is a 30 ampere, it means this is a 10 ampere and this is a 10 ampere. Now in order to give 40 ampere out of this, it means 40 ampere is divided by 2. We are going to need 2 of this one linking in parallel. So I'm going to call this is the end of part 1 of fixing this ATX Delta power supply DPS, model number DPS dash 250 AP-24C. Bye.